Whatever, yay! We're gonna talk about making PySpark awesome. We're gonna try and cover a whole bunch of things, and we're definitely gonna cover one of them really poorly. And it might be the last one on that list. Cool. And so yeah, my name is Holden. My preferred pronouns are she or her, and I'm a developer advocate at Google. I am on the Apache Spark PMC, and I contribute to Beam and other open source projects. I work together with Bryan at IBM, and I've worked at a lot of other places which do fun things with data. And I'm a co-author of 2 books on Spark. I think you should buy the second one. It wasn't until that book that I realized you could negotiate royalties. Pro tip, if you're ever gonna write a book, negotiate. Other pro tip, buy several copies of this book. You can follow me on Twitter if you want. Slides will go on SlideShare. If anyone's curious in learning more about how Spark itself is developed, I've started doing live streams where I review people's code. And I would always love more watchers, and you can ask questions. If you contribute to Spark and you're willing to let me review your code live, you can also message me and opt in, and I promise to be very friendly. You've had some of your code reviewed live. Have you watched any of it?
Yeah, you did a great job.
See, and so it's definitely a wonderful learning experience. And you can also check out some of my other talk videos. In addition to who I am professionally, I'm trans, queer, Canadian, in America on an H-1B work visa. Oh my God, so much fun. And part of the leather community. And this is not directly related to Spark. There is no secret Canadian garbage collector that we have been hiding from you. Nor is there a secret Canadian debugging Spark manual. This shit doesn't make sense to anyone. But I think it's useful to remember that we all come from different backgrounds, and if we work together, we can get through this shit a lot faster. We can make really cool collaborations between projects like Arrow and Spark happen, but if we spend all of our time fighting with people, we'll just burn the world down with big data, and that'll be really sad. I can still sell support contracts or whatever, but it'll be kind of depressing.
Happy Pride.
Yes, thank you. This month is Pride Month, and actually, if anyone's interested in riding with a very legitimate scooter club that is definitely not a gang, the Sparkling Pink Pandas is a queer, trans-focused scooter club in San Francisco that I help organize, and we're always looking for new members because roughly 10% of our membership goes to the ER each year. So come join us, and don't go to the ER. Okay, relatedly, if you are an SF resident and US citizen, you can vote today in the primaries. That's the thing. I don't understand the American political process. I don't know if I want to anymore. And you can vote even if you haven't registered yet. There's some online instructions on how to do that. And so please vote, and vote for people who aren't assholes. Cool. Oh, right, okay. So I'm hoping you're nice people. That slide, yeah, and the happy pride thing, like, yeah, clearly nice people. I am really curious, how many people know some Python? Yay, friends! Okay, how many people are completely new to Python? Is there anyone? No one. Okay, cool. Well, that makes sense. This talk probably is more interesting to people that know Python, but if you're like new to Python and just afraid to mention it, we're really happy to have you new as well. I always like new people. Hopefully you're interested in distributed systems, but possibly you don't care and you just want your software to work. Either way, hopefully this will be somewhat useful.
Dude, can you show the notes by any chance?
Oh, fuck. Oh shit, my microphone is still live. No, because it's in like mirror mode. Are you good, or how badly do you need your notes?
We'll see.
Okay, cool. Do you want to like introduce yourself, and I'm gonna put the notes on while you're doing that?
Sure. Hi, I'm Bryan Cutler. I'm a software engineer at IBM for the Center of Open Source Data Technologies and AI Solutions. We also call it Code for short. Our goal is to make AI easier to create, deploy, and manage in the enterprise. I'm also an Apache Arrow committer and Apache Spark committer. And I primarily work in open source software, so feel free to ping me on GitHub or with any questions or any kind of code reviews you would like. Got it?
Yeah.
Cool, thanks.
Yeah, okay, you have speaker notes. We're fancy.
Okay, what we're going to go over today, we're first going to briefly cover Python usage in the big data ecosystem. And we'll go over a little bit about the architecture of Python and Spark. I'll cover some recent additions made with Apache Arrow and explain how that helps our situation dealing with some Python issues. And we'll talk about how to set up multi-language pipelines, and then go into how to manage your Python dependencies within your Spark cluster, and possibly some other fun topics if we have time. So I'll throw it back to Holden.
Rockin'. So I think it's important to remember, especially as we talk about how to make Python work well in the Spark ecosystem, is part of what I think has led to Spark's success is integrating a lot of disparate tools. Traditionally, if you wanted to use machine learning tools and SQL tools in the big data space, you had two separate systems to deploy, separately update, and try and copy data in between. And also traditionally, if you wanted to use multiple languages, you had separate tools where you had to copy data in between manually. And this is both slow and error prone, especially if you're using object stores, which don't behave quite like HDFS. And so I think Spark is really awesome, and part of it has come from being this big integrated tent of happy project families. And so I want to be clear, especially because I gave like an early version of this talk once, and someone came up to me afterwards and was like, wow, Spark sounds terrible. What should I use instead? And it was like, oh, no, everything else sucks too. So I want to be really clear. We do a lot of bad things, but I don't know anyone who doesn't. So that's good. And with that motivational message, we'll continue. So other tools outside of Spark also follow this same general approach. They tend to use a combination of pickling, strings, JSON, and some of them looked at that combination and said, you know what this needs? Some enterprise-ready XML to handle my data interchange for me. And that surprisingly works. Not like well, but it works. And often we end up communicating over Unix pipe sockets, and the Flink folks use memory map files because they're fancy. But generally, all of this still kind of sucks. The other option is like the Kafka people have 3 different approaches for integrating Python, and they all have different trade-offs. But most people just follow this one sort of general approach. And so let's talk more about PySpark and how it works today. It's the Python interface to Spark. It's pretty mature. It can feel like it's not if you're using it, but it is. And it has some performance hurdles from the initial design. And this is what happens when you build something cool and maybe don't think it through all the way. But that being said, we looked at the mistakes we made and decided to repeat them again for every other language we brought into the ecosystem. And so we went, you know what, that's kind of slow and hard to debug. I bet that would be a great way to support R. And then we did it again for C#. And the Julia folks looked at it and went, oh, God. And JavaScript is surprisingly different. Are there any JavaScript big data users in the house? Come on. 1. OK, we can be friends, and we can talk afterwards if you want, but you also don't have to, because I'm perhaps unreasonably excited about this stuff. It's really cool. We'll talk about it later. OK. And yes, of course, so this is a Spark conference. You've probably seen word count, but as a licensed big data instructor, I'm not allowed to give a presentation without a word count example. And so we had to put this in here. And you probably recognize this. And so it's important to note that like these lambdas are combined for the most part and executed together in Python. We don't have to copy the data for each one. The difference is the reduce by key is in a different stage. And so we have to copy the data again for that. But we have some cool pipelining benefits. So PySpark works with pickling, sockets, pipes, and JSON, which I still, one person suggested I get like one of those scary masks for JSON for the murdering people, and I was like, that's a little too close for comfort. And so this is how PySpark works. And what are the different pieces used for? So on our driver program, we use this thing called Py4j. And when it works, it's great. It's not very fast, but the driver program doesn't have to be very fast. It's not copying a lot of data normally. On our workers, we use pipes. We use a custom serialization library because why not? Not only do we use a custom serialization library, we just copy cloudpickle.py into our repo every 6 months or so and call it an update. I'm still working on convincing people that we should take a dependency instead of doing that. And then we use JSON for data frame schema information. And surprisingly, this all works, which is pretty amazing. And so what does this look like? So we have our Python process communicating to our Java process with Py4j on our driver program. Our workers will get the Lambda expressions that have been sent from the driver program, take the Lambdas, send them into the Python worker, because Java doesn't know how to handle a Python Lambda, and it'll get ready to evaluate some data, but then Python doesn't have the data either. And so then we start sending the data over from the JVM to Python, evaluate it, and send it back. And then if that sounds slow, it is. Yay? So right, the double serialization cost makes everything more expensive, and the error messages make no sense. Today, we're only going to deal with the first problem, and the second problem is, as we say in open source terms, pull requests welcome. And I'm actually being serious here. If you want to help us improve our error message reporting, I would be very excited to work with you on that. I am just really lazy and don't want to do that. OK, cool. So that's all bad, but we could do something else instead. What about if we just got rid of the second part where we copy the data and the Lambda expressions? Maybe we could just figure out how to evaluate the stuff inside of the JVM, right? What could go wrong with that? OK, foreshadowing is maybe not my strong suit, but it turns out many things can go wrong, but it can go a lot faster. But before we get too far, I want to be clear. Spark data frames, just in case you're newish to this, are not pandas data frames. If you want that, you want Dask. Or a very expensive support contract. But so they don't support everything that pandas data frames do, but they're pretty good. And if we write in this restricted sort of subset, Spark is able to handle its evaluations inside of the JVM. So we can still write Python code, but it'll actually run in the JVM to some degree. And so here's a wonderful example. And this is nice because it's word count, again. And here we tokenize some text, but instead of using a Lambda expression, we're using sort of Spark SQL built-ins to express all of the things that we were doing before. And so even while we wrote this in Python, this is evaluated in Java. The only downside is this code looks really similar to the first piece of code that I wrote in my professional career, which I later then had to internationalize to Japan. And it turned out that spaces didn't work for tokenization anymore. And then my life was kind of sad. And unfortunately, there's no built-in Spark SQL tokenized Japanese function. And it turns out there's also a lot of other functions that are available to me with Python libraries that don't have a matching Spark SQL built in. So while this graph strongly implies that it's very fast, but will not do everything you want it to. Yeah. Yay. Also, this graph is made by a vendor trying to sell you something. So consider how much they're lying. OK, another option. What about if we put Jython inside? What could go wrong? OK, I hear laughter from people who have used Jython. And for the rest of you, congratulations. I essentially got really, really excited around the same time I got my Adderall prescription for the first time. And I, legitimately, ADD, as you can probably tell, and decided I was going to make this work. And I did. I made a PR. Yay! And then people were like, but I can't do anything useful with it. Oh, wah, wah. So it turns out we can get really close to native performance if we just compile all of our Python code into Java bytecode. The only catch is we just have to use Python 2.7 and pretty much no libraries. That went over about as well on the mailing list as it did here. And so that did not move forward. That being said, though, I am always trying to collect Python UDFs for benchmarking. And if you are willing to fill out this survey, please do. And then we can start having benchmarks, which aren't just me running word count on different data sets, calling it an industry benchmark. Right, okay. So the alternative to this is to go like, maybe instead of trying to bring my computation into the JVM, what I can try and do is make it so that bringing my data from the JVM to Python sucks less. And in Spark 2.3, we have that, yay! The only catch is it has a bunch of bugs, because it's new, and if you have data with time zones, I'm really sorry. Yeah, that's not gonna work. But it might work later, so that's good enough. Just encode everything as longs, and just write the time zone code yourself. What could go wrong? Okay, in addition to this currently being used for Python, we can use it for other things as well. But that's definitely in the what's called future areas of exploration part of the paper, also known as things I would do when given a grant. But I work in industry, so now it's more just things that we would do if I tricked my boss into paying me more. So yeah, your data can move as fast as this cat sees different universes while eating catnip. Yay! And so I want to be clear, this works in Spark 2.3. I think it's probably the future that we're moving in. But I thought a lot of other things were cool too, like Pokemon. And like, Pokemon cards maybe were not the most sound investment. And so I could be getting this one wrong. But I'm going to hand it back to Bryan to talk about how this kicks ass.
All right, thanks, Holden. I'm going to talk a little bit about how Apache Arrow is being used in Spark to solve some of these issues that we're dealing with Python. First, a little bit about Arrow. Arrow is a in-memory columnar data format, and it's meant to be a standard to transfer data in between different systems. So the format definition itself is language agnostic, but there's several key implementations and libraries in Java, C++, and Python. So this can help avoid issues like costly serialization, and it lets you efficiently use large chunked array data. So internally, Spark uses this to transfer data from the JVM to a Python process. And this is especially useful for evaluating Python UDFs, also known as pandas UDFs. So looking at Arrow from a high-level point of view, it's not just for transferring data from Java to Python. Arrow can be thought of as a common way to bring together many different systems in the big data world that might otherwise require a lot of different specialized code in order to talk to the JVM. Also, another important point of Arrow is that for non-Java applications, it can also read and write the Parquet data format, which is the big data standard. Arrow is still pretty young, but in the last year, it's seen an amazing growth. A lot of new people are adopting it and using it and adding new implementation languages along the way. So I encourage you all to check it out and get involved as well. All right, let's look at a simple example of a Python UDF written with Arrow. This is just a simple function that adds 1. But the way that Spark evaluates this is by creating pandas data to use as input for the variable x. Then x can be processed using a vectorized manner and take advantage of hardware acceleration and SIMD operations in order to quickly produce a result, which is also pandas data, that can easily then be sent back into the Java JVM. I was going to go here. So this can have a huge different performance impact depending on what kind of UDFs you write. So here's some comparisons about 3 different UDFs. Of course, it depends on what you're doing inside the UDF and what kind of data you're transferring back and forth. But even with our simple +1 example, you can see that we achieved over a 3 times speed up.
I want to throw in here.
Yeah.
Please do not trust us. We worked on this. You should not trust us.
Yes, verify for yourself, So let's look in detail on what a Python worker looks like while it's processing these UDFs with and without Arrow. So without Arrow, the JVM needs to take each individual value and serialize it into a pickle format so that Python can then read it and consume it, and then also must deserialize each value to produce a record, apply this UDF to it, and get a result. And this is repeated over and over again until all these records are consumed. Then it needs to go in the reverse direction in the same manner. So using Arrow, things are now a lot more simple and efficient. Java can directly make an Arrow record batch, which is a large chunk of data, and send it to Python without any kind of data serialization. Then in Python, it can immediately consume this data and use pandas to process it and get a result back in pandas as well, and send it back as another Arrow record batch, again, avoiding serialization. Now that we have this efficient way to transfer data to and from Python, it becomes a lot more practical to start integrating some of these great packages that are available in Python. So going back to our word count example, we can create a pandas UDF that uses the Python package spacey that does natural language processing to do the tokenization. Now this gives us a way better tokenization and allows us to use configurable languages. So here, the input is just a pandas series of text documents, and we use pandas to apply this spacey tokenizer to each document, and then also returns a pandas series of string arrays. Now, taking this a step further, we will probably want to connect our new UDF into our machine learning pipeline. Currently, the existing Spark MLlib stages are all Java-based, so this will end up creating a sort of multi-language pipeline. And to make integrating this a lot less painful, it would be really nice to have just a simple way to plug in your little bit of Python code. And you can always try to hack up your own solution, but that's sometimes difficult because there will be a lot of boilerplate code dealing with Spark, and it's not easy to, it's not always easy to work within the existing Spark ML framework. So fortunately, there's an open source project called Sparkly ML. This is a, excuse me. This is,
You got this.
this is, sorry about that. Sparkly ML is a library extension to Spark that adds additional estimators and transformers. And it allows you to easily write your own that nicely fit in with the rest of Spark. It also makes it easy to integrate a pure Python stage into a standard Scala-based pipeline. Thank you. Now with our spacey UDF, we can easily just make a few changes to it and automatically get this new machine learning pipeline stage using Sparkly ML. So now that we have our spacey tokenization stage, we use it to build this mixed language pipeline, and we can fit that right in with the rest of Spark, using Spark SQL to feed our new pipeline, and use an existing Spark cross-validator in order to tune it. Now that we have our spacey word count, we ended up racking up all kinds of different Python dependencies. We're using spacey, PyArrow, pandas, and a number of other different Python packages that those also depend on. And it brings up this other tough issue with it's difficult to manage this in a cluster. We need to make sure that all of these packages are installed on each node and that all the versions are compatible with each other so that nothing ends up breaking. We ideally want this to be easy for a user to add or remove new packages. And we want this to be able to be done without needing administrative privileges within the cluster. So there's a couple different options that you can approach using this. Different vendors have different ways of doing things, so there's obviously that. We're going to take a look at option 2, which is using some sketchy open source software called Coffee Boat. Okay, so Coffee Boat is an available Python package. It's currently in alpha stage, so you need to go to GitHub through GitHub to install it. Once you fire it up, you simply add your Python packages that you want in your cluster, and then you go ahead and start your Spark context. Now, behind the scenes, Coffee Boat will make a local Conda environment with your defined packages and deploy that throughout your Spark cluster. And then it will make sure that Spark is properly configured in order to use this new virtual environment. What's great about this is that the virtual environment in your cluster, you can be ensured that it's exactly the same as your local environment that you made. Okay, I'll throw it back to Holden.
Rockin'. So Kubernetes plus PySpark. The first thing is that doesn't work. But it's totally probably going to work soon. And if you want to tune in on Friday, I'll be doing a live code review of that pull request, which hopefully has the integration tests I've been asking for. If not, it'll be a very short code review where I just go, please add integration tests, submit. But so I think once we have that part integrated, there's a lot of open questions. Your Docker image base might not have all of the libraries that you need. That being said, it's a lot easier to build a new Docker image than it is to configure your Yarn cluster. And so for now, we can edit scripts to add support. In the future, we could make it a lot simpler to run on top of Kubernetes with the dependencies you need. There's some open question as to how we want to handle sort of this last case, which is adding that last-minute package that you just forgot just this one time for reals in your notebook halfway through when you realize you had everything except for your magic, which you need. And so how we want to handle that is definitely open to ideas, and please join us on the dev list. What's great is we're running out of time, and so I have an excuse for this slide to be one slide. There's a lot of really cool graphing libraries in Spark, not so much. But I think one of the things which is pretty exciting is the Interact folks have been working on sort of a new standard way for us to communicate that we have a data frame-like object. And we've been talking about it. You can see the repr pull requests coming through in PySpark. And I think what would be really exciting is if we agree to use this format, and then people can have pluggable graphing options in their notebook as they desire to perhaps match or compete with some of the commercial offerings from people I no longer work for. Yeah, OK. Why now? The TLDR is big data is cool, but now so is deep learning, and people in San Francisco are like, I gotta get me some of that deep learning. I don't know what it is, but the VCs won't invest. And as much as we laugh at that, I think that's the depressing truth. Like, we've had a lot of options to make it better until now, but now people are actually willing to do the work because they want to raise their money. And that's fine. It's just depressing. Bunch of resources. I keep saying I'm going to write this blog post soon, but I almost burned out last month, so I didn't. I just kind of went to Disneyland, which was pretty great. I got some photos from the cars ride if anyone's curious. But yeah, that'll come next month instead of 2 to 3 weeks. I didn't have the energy. I'm sorry. But we're getting close to my favorite slide. And it's not this one. These are all of the Spark books. This is my favorite slide. High Performance Spark. This is the book that you should buy today with your corporate expense account. It is great. Cats love it. And also, relatedly, if the cat pees on it, Amazon will not accept it for returns. So I think you should definitely let your cat play with it. I think this book is so cool. I got a tattoo of it on my shoulder last week. I don't know, whatever. So I hope you like it. If not, it's not going anywhere. It is totally unrelated to this talk. But that should not stop you from buying it, like at all. I'll be giving a talk tomorrow on how to do TensorFlow with Arrow and shit. If there's any like Scala people secretly hiding out in the room, you can come join me in New York. Next week, I'll be in Berlin for 2 conferences. And that's why that blog post is not happening this month, sorry. And you can come join me at some of these other parties. Bryan's got another talk in the session right after this one.
2 sessions.
Oh, 2 sessions, okay. And you should definitely also check out Bryan's talk as well. And so that's pretty much it for us. I got a bunch of like survey links here, as always. If you're willing to share any information with you, I promise to use it in a GDPR compliant way. That gets a lot more laughs in Europe, by the way, and groans. So thank you all. I think we're near the end, so probably no time for questions. But I am wearing a pink dinosaur dress. You can probably find me outside. And if there's another person wearing a pink dinosaur dress, I would love to meet them.